Hi everyone, I'm Trent, and it's my pleasure to be here. Thanks for having me. So let's get started. Today, I'm going to talk about a public database for the planet. Let's get started. So let's say you walk into a supermarket, and you want to buy some bananas, or a banana, you're really hungry. So you go to the banana section, you get your banana, and you go to checkout. But weird, there is no checkout. So you think, well, this is strange, but you're really, really hungry. So you take that banana, you walk outside, hoping that you'll just pay them next year, and tomorrow, the day after. But as soon as you walk outside, a gigantic, super strong security guard tackles you down and says, "That'll be $5,000 for that banana, please." Sound ridiculous? Well, this is exactly how a lot of the modern web works. When you go to get an image, maybe you want to use it for a talk like this, but there is no way to license it. It's really easy to just use, right-click copy, but there's not any way to go right-click license easily. It's kind of strange, right? Let's talk about another challenge that we have with the modern web. If you go and use Facebook or Gmail or any of those, well, what's going on? You're not paying for it. It's kind of a cool service, you rely on it for email, to connect with your friends and so on. But there's this old saying, if you aren't paying for the product, you are the product. What do these companies get in return? Your data. Right? Each of them has giant data silos having your data. They're monetizing you. That's not very cool in my view, although frankly I still use these services largely because alternatives haven't emerged in any major way. So one way to kind of summarize all of this of what's going on is what someone on the Shapeways blog said, my conclusion is that whatever you put on the internet, you lose it. Maybe you keep the rights, but you lose the power over it. This might be a photograph you've taken, no one's paying you for it. Maybe it's some of your personal data about the things you've done. Others are monetizing, but it's really hard to make money directly yourself. So to kind of summarize, there's these existing systems of power creating unequal outcomes. Creative works, it's kind of backwards. Other stuff, it's really hard to use legally to pay dollars for. And with your stuff, it's hard not to lose, really backwards. And your data, your personal data, isn't really yours. You've got these walled gardens. You can't really share how you want. And these data silos, you can't take your data with you if you want to leave. But we've been asking the question, what if you had a place, a database, to put your stuff? And on that database, no single entity owned or controlled it. Instead, it was a shared database for the planet. Encrypted and all these things, of course, to control, to manage the data yourself, but then you give out the keys, you give out the permissions to use as you feel, right? Think of it like the DNS, except for everything else besides just mapping domain names, and more decentralized. So we see that there's really two parts of this. There's the actual software itself, a blockchain database software. This is sort of the dream of blockchains, these public nets, but traditional blockchains simply haven't had the scale, right? So a blockchain, but it's also a database in the sense of it's actually storing data like any good database should. And not only this though, you need not only the software, but you need a network running this, some sort of well-governed instance of this that together no one owns or controls. So what I'm going to talk about now is what this looks like. This is what we've been working on for the last several years, and we're pretty excited. So first of all, this blockchain database software. So it's a database with blockchain characteristics. And we call it BigchainDB on purpose. It's got the word DB, because it's a database, and got the word chain. So let's think about databases for a second, right? So most of you in this crowd, I assume, are technical, so this probably doesn't need that much explanation. But let's think about it anyway. So let's say you've got a spreadsheet or even a CSV file. What is the difference between that and a database? The key is querying, right? You've got some sort of language, whether it's SQL or some other language, to query this data. You write one line of code, and from that, it very quickly retrieves all the records related to that query. For example, give me all the males over the age of 40 who live in Berlin, right? And it will go around and search through possibly millions or billions of records and return that very quickly, right? Now, you could do this just by looking through a CSV file yourself, but that would be slow and cumbersome and probably errors too. And with this concept of querying, et cetera, this is the house that Larry Ellison and Oracle built starting in the early 80s, right? And Larry Ellison, he's become one of the wealthiest men in the world, but he does have a sense of humor. This here is actually the Oracle headquarters right near the San Francisco airport. And it's actually shaped like a database icon. So as you drive back and forth to the airport in San Francisco, you'll see these. So remember, this is a database icon. It's kind of cool, right? So it was really the first sort of blue ocean database. It was really the very first database company that did well. But in the vein of blue ocean, in the sense of rather than the sea of sharks swimming around competing on the same specs, along came MySQL in the early 2000s, and they said, we're not going to be sort of enterprise class, these big, heavy monoliths that Oracle's shipping. Instead, it's going to be small and lightweight and really easy for startups to deploy and use, right? Internet startups in particular. And that's really what MySQL did. They made it open source, and they were a big, big success as well, right? They were bought by Sun. Ironically, eventually Sun got acquired by Oracle, so it ended up in the same place. The MySQL founders aren't too happy about that. But overall, it really was a new sort of blue ocean database. But the blue ocean databases didn't stop there. As the web continued to explode, scale really, really, really mattered. So, and at first, there was these scalable databases built within the big internet companies, within Amazon, within Yahoo, et cetera. But then they started to be open sourced, and the concept's open sourced. And probably the biggest winner here has been MongoDB. And basically, the main benefit has been to get to big data scale, to handle large scale by adding commodity hardware, horizontal scaling, as well as flexible schemas, speaking the language of JSON rather than traditional SQL. That's much easier in some cases. So Mongo really won that. There's others too, of course, data stacks with Cassandra, et cetera, et cetera. So this was a whole series of blue ocean databases. And you might ask, well, how do they scale? And the answer is sharding, right? No single shard, no single node is storing all the data. Instead, each node stores a fraction. So if you've got 100 terabytes being stored, maybe one node stores 1 terabyte and another node stores another terabyte. And of course, you've got a few backups of backups too. But overall, that's how you get to scale. And of course, these things are kept in sync via a consensus algorithm. So the consensus algorithm is simply such that all the nodes can agree on what the value of x is. Say x equals 2. OK, great. And these have really nice properties. This here is a plot of Cassandra scaling. So the x-axis is the number of nodes. The y-axis is the throughput, the number of writes per second in this case. And you can see with 50 nodes on the bottom left, at that, Cassandra could have about 175,000 transactions per second, which, by the way, is quite good already, right? But what's pretty interesting, as you add more and more nodes, horizontal scaling, then the throughput goes up higher and higher and higher, linearly. So this is quite impressive, and this is results from 5 years ago. Things have become even more advanced now. But so you've got more throughput, and of course, obviously, you have more capacity too, because of the sharding, right? Now you might think, well, duh, of course. But in the world of blockchain, which is where I spend a lot of time, the equivalent of this for Bitcoin is it would be a white line hugging the x-axis, right? Bitcoin actually has 7 transactions per second theoretical, about 2 transactions per second in reality, and they call it bloated when it's only storing 80 gigabytes. I can store more on a thumb drive, right? So, so you compare that to modern big data databases, it's a world of difference. So what we've been doing is saying, hey, let's figure out a way to leverage all these advances in big data databases and bring that into some of the dreams, the visions of the blockchain world. And so we see that actually a blue ocean database, the next one is blockchain databases. It's a database by traditional standards that also has blockchain characteristics. And there's 3 characteristics: decentralized, immutable, and assets. And each of these characteristics, together they're blockchain, and individually they're quite interesting. Decentralized means no single entity owns or controls. So you could have a consortium controlling this, or you could deploy it in a public way where then it's actually sort of a utility owned by the planet. Immutable, this is basically like a traditional logging database. The idea of once you've written to it, it's kind of there for good. No such thing as absolutely immutable, but you can get more immutable than traditional means. And finally, the idea of assets. So I can issue an asset onto this thing, a token of value, and then I can transfer that from myself to the next person and the next person. Think like Bitcoins. Those are assets that are actually intrinsic to Bitcoin. But of course, you can have this for digital art or whatever. And I'll give many examples later. So this is actually what we've been building, this software that basically merges these 2 worlds to get to planetary scale. We call it BigchainDB. And we said, why reinvent the wheel? Why not leverage some of the best-in-class technology out there? So we actually built on top of MongoDB. We figured out a way to blockchainify MongoDB. We actually also wrap RethinkDB, and there's more on the way. But how this works is basically MongoDB at the core. It has a bunch of different nodes, and they have their own consensus algorithm, such that all the nodes sync up. And this is fault-tolerant consensus. And what they have is a derivative of Raft for those of you who are consensus nerds. And then what BigchainDB does is each one of the nodes of Mongo gets wrapped by a BigchainDB node. So instead of just a deployment of, traditional MongoDB might be 15 nodes controlled by one sysadmin, now you have 15 nodes controlled by 15 different sysadmins from 15 different organizations. And basically, BigchainDB is adding this sort of outer layer to have not just fault-tolerant consensus, but consensus where there's voting among the nodes about what goes through and what doesn't to prevent double spends and other malicious attacks. So this is kind of the architecture of BigchainDB. And to summarize in this, what it is, it's bringing in the best of both worlds of blockchain, sort of the vision of traditional blockchains, where you've got immutability, decentralized control, and assets, but also you've got the scalability and queryability of modern databases. So that's the first part. Basically, I've described to you at a very high level what a blockchain database looks like, right? There's another part, though, of course. Once you have the software, you really want to have a public network that people can easily use. You can roll your own consortium with your own federation and so on, and that's fine. But it should be really easy to use for people to go out there and just use this database. Think like MongoDB Atlas without the MongoDB, right? Or Google Spanner without the Google, right? And just a service out there for people to use that's sort of a public utility owned by the planet. And that's what we call IPDB, Interplanetary Database. So what it is, it's designed from ground up to be for everyone everywhere. It's set up such that you use it as if you use any other web service, software as a service, database as a service. And the heart of IPDB is caretakers. So there's about 20 caretakers, and they have two roles. Together, they run a nonprofit foundation so that you have governance of the protocol and any other decisions that need to be made. And also, each of the caretakers operate one of the nodes. So that is basically the core of it. To give you a feel, though, you can't just have any caretakers. If you have 20 companies that are all trying to make money on this, then you might be captured by dollars, right? And this is actually a real problem that even happened with DNS, right? DNS, there was the core registry, but then it was wrapped by the registrars, and the registrars over time effectively captured the governance of the registry. They captured ICANN, right? And by the way, the creators of the DNS are pretty sad about this, right? David Holtzman, Jim Rutt, Esther Dyson, Pinder Wong, they're all pretty sad that ICANN has been compromised. This is why we have things like .sucks as TLDs, right? That was never part of the vision. So there was sort of this dollar capture that you want to avoid. You also want to avoid jurisdictional capture. An example here is, right now, more than 80% of the hash power of Bitcoin is in China, right? So it's effectively captured jurisdictionally. China could close down its internet, and then the mining, the Bitcoin network would partition in two. And that's actually not very good for humanity, right? This is infrastructure that we want for humanity overall. So for the caretakers, we said we need to have at least half of the caretakers to be nonprofit to avoid money capture. And to avoid jurisdictional capture, any given country can't have more than half the nodes. So overall, the caretakers that we brought in to help run this thing, and now they are running this German nonprofit foundation called IPDB Foundation. We've got folks like Internet Archive, Koala, Dyn.org, Open Media Foundation, and more. And a few for-profit companies too that actually are building the next generation infrastructure along this. There's BigchainDB, Protocol Labs, the guys building IPFS. So IPFS is a file system that sits side by side with IPDB. So interplanetary database, interplanetary file system, and more. So these are the caretakers that are collectively controlling this and running it. So that's kind of the summary of the building blocks. You've got the software, BigchainDB, and you've got the network, IPDB. You guys probably you guys are mostly software developers and so on, so if you ever want to play with this, it's open source, all of this, so you can go to GitHub and play with it, download it, and so on. And if you go straight to BigchainDB.com, click Quick Start, then you can go through a tutorial and be going in 20 minutes. And kind of our view is it should look, act, feel like a database. It shouldn't take you a week to learn some new language and so on. Instead, why not just use it like a database with some of the benefits of blockchain technology? And to give you a feel here, this is sort of how you might use it. So this is off of the Python driver, but there's also a JavaScript driver, a CLI, and other drivers from the community, Ruby, C#, and more. So if you're writing some Python code to write to this thing, then the first thing you do is you can create a payload or create an asset. And then you create a key pair. This is really your identity, right? Private key, public key. And then you create a transaction. You sign that transaction with the key pair. And that's basically saying, yes, I myself saw this. And then you basically dump that transaction to the network. That's the very bottom line here. And that's really the essence of creating a digital asset. It takes all of 5 lines of code. Once you know this, it takes you 2 minutes. Even going through the tutorial, it takes 10 minutes, and then you're done. And if you want to look at what you've created, you can read it back, and it's simply JSON under the hood. There's a set of inputs, a set of outputs, and a payload. So very straightforward. If you've ever tried to program on Bitcoin and stuff, it's a huge pain in the butt. One of our users said, what would take a month on Bitcoin takes a day on BigchainDB. And we're not actually trying to compete against Bitcoin. We're really trying to be a database, but to kind of give you a flavor here. So overall, you might ask, what are the different ways that I might deploy this in terms of stacks and so on? And I'll talk about a few. So for reference, obviously this morning there was a lot of talks on containers and so on. And we actually use things like Kubernetes under the hood. But overall, as a stack, if you've built on cloud stacks, you might have something like the following. For a file system, maybe you're using S3, maybe HDFS, whatever. For a database, maybe Mongo, maybe side-by-side with MySQL or Postgres. For processing, you might have EC2. And then as a platform, maybe you're running AWS, maybe even Heroku on top or something. And then your application running on top, right? Pretty straightforward. This is centralized, although distributed infrastructure. So when I say distributed, I mean that the compute resources are spread across more than one machine, but it doesn't have anything to say about control. So distributed is about spread of resources. Decentralized is about spread of control. Then if you go to blockchain, you hear about the rhetoric in blockchain world, and people kind of use the word blockchain to mean everything. They mean it to use processing and file system and database. You have this giant magical thing called blockchain that just does it all, right? And that doesn't really make sense, right? Here we've got Bitcoin, magic internet money wizard. But this doesn't really make sense if you've spent any time creating software, right? What makes more sense is to start saying, hey, what if I want to start with my existing stack, cloud stack, and just add in one more database, right? So side by side with Mongo and MySQL, I've just also got BigchainDB running, or maybe on the public net, IPDB, right? So that's one way you can do it. And maybe that stores tokens of value for maybe some rewards program or whatever. But you can keep the rest of your stack. You don't have to throw anything out. That's a really nice way. Now, of course, if you want, you can go much more full-blown. There actually is an emerging ecosystem here where each of the building blocks are being built by various parties in the blockchain world. So you might have heard about Ethereum. That is essentially decentralized processing. It's a better label than smart contracts. So Ethereum is there. Side by side with Ethereum, we've got things like Hyperledger, Tendermint, Lisk, and so on. For file system, I've already mentioned IPFS, Interplanetary File System. For database, I've talked about BigchainDB. And there's sort of this new thing, sort of a ledger of value. And this is really where Bitcoin or Zcash, these sorts of technologies emerge. And on top, there's even platforms to manage this that combine the technologies together. Things like Monax, block apps, and so on. So this is a way, if you want, you can actually build an application that uses these different building blocks together. And we're seeing this emergence now of applications that have many of these pieces. There's another thing, though. Some of you guys might have used Lambda, right? AWS Lambda. It's pretty exciting, right? It's serverless applications. But of course, it's still being served up by Amazon. What if you could have Lambda without the AWS, right? Or just like, Atlas without the Mongo, right? Well, so this is another architecture that we've seen emerging where you've just got your client-side app, right, running code, and it's, JavaScript in the browser with React, whatever, or maybe your mobile app. And then under the hood, you've got your structured data, and maybe assets, tokens, et cetera, all in IPDB, the Interplanetary Database. And if you have any media blobs, et cetera, this is what you would put in the decentralized file system, IPFS. So this is a dead simple thing, and we've been starting to see deployments like this. For example, in our company, one of our developers, in 3 weeks, built a full-on decentralized data marketplace. Just a single web page app. Under the hood, it's got IPDB and IPFS. So those are some examples of stacks and deployment. Now, for those of you not in the blockchain world, you might be interested, how do I use this, right? Is this some whiz-bang idea that has no application? Well, in our experience, we've actually seen a lot of applications, and we started there, actually. We started with something called Ascribe 4 years ago now, which was IP on the blockchain, but specifically, in our case, for creators of digital art. So there has been this long-running problem in the art world. If I'm an artist who creates digital art, how do I sell this to someone? If I'm a creator, what am I buying? How do you collect digital art? And where we started actually was saying, what if you could own digital art the way that you own Bitcoin? And we had pulled in that thread, and realized the answer actually made sense. Yes, you could do this. And that's what led us to building Ascribe. So with Ascribe, you can actually register any digital art or photograph or whatever you create. and then you can transfer it. You can transfer editions one at a time from person A to person B. So this is a scribe, and this was the initial vision. What led us from the path from a scribe to BigchainDB and IPDB was scale. Like I mentioned, Bitcoin simply doesn't have the scalability properties we need. And these days, by the way, too, it costs $3 per transaction, so a little bit more expensive. So this whole low fees thing kind of went away. A lot of that is just simply some of the technology choices inside Bitcoin that you don't have to have anymore with BigchainDB. As you've seen, you can leverage a lot of existing consensus technologies, in some cases going back to the 80s with BFT, this sort of thing. So this is a scribe. It's basically an app for IP on the blockchain. Another example is Authentic. This is towards the sovereign personal data angle. So rather than your data being stored by Facebook and LinkedIn, et cetera, instead, you've got it stored, encrypted yourself. You own the keys, and then you dole out permissions to others as you see fit. So this is the vision that Authentic is working towards. They're starting out with simply KYC in the blockchain. So rather than going to one bank and having to go through a whole KYC process and then another bank and then another, instead, you've actually gone through that process once, and from that, you can deploy this vetting to whatever applications that need it. And this is quite important, actually. If you're doing applications that have any transfer of value, then you want to have better identity vetting than just saying, email or social media handle. Another one that I'm quite excited about is music. So there's been a lot written and dreamed about in the world of music and blockchain for years now, actually. Everyone from Imogen Heap, George Howard, all these folks talking about this. And there's actually several companies building, working with us. One of my favorites is Resonate. So Resonate is a decentralized streaming platform. Think like Spotify without the Spotify, right? And so they're building on top of BigchainDB and IPDB. And overall, you can basically stream. And they have a twist on this too. You can stream to own. So once you've listened to a song for about 10 times, then you actually have the rights to it to play it all you want in the future without having to pay anymore. Resonate itself is not a company. It's actually a co-op. So it's owned by all the artists, et cetera. So you'll hear a lot more about these guys in time to come. It's pretty exciting. Of course, besides the startups, there's also the big organizations, the big ecosystems, and we're working with several that are emerging. So one project is called Genesis of Things, and this is a project led by Infoshare, but also involving Intel, Cognizant, and others. And the idea here is basically about the 3D printing supply chain. So starting from the CAD file in the engineer's desk, all the way to the manufacturing and all the steps in between, there's multiple players in this ecosystem. What if you actually had an underlying ledger, an underlying blockchain database that kept track of who owned what was licensed where, and so on? Another example that makes me pretty excited is BenBen. This is a land registry for Ghana. And you might think, well, what's interesting about that? So there's this famous economist, Hernando de Soto, and he worked with a lot of countries and organizations over the years to help identify how to bring people out of poverty. And what he realized was the very bottom rung of the ladder out of poverty was title to your land. In places like Brazil, where you have these favelas, families have lived for generations, but they don't have title. And without title, they can't get a mortgage, they can't take a loan to get it, to start a company, to get an education, et cetera. But what if suddenly you actually had titles that you trusted? The problem is, somewhere like Ghana, there's been so many military coups, the government registries aren't trusted. But if you now put the registry onto this public blockchain database that no single entity owns or controls, then you can start to have trustworthy title. Then people can have mortgages against the title. Then people can start companies, and you start to climb out of this ladder of poverty. This is exactly what BenBen is doing. They're starting with Ghana, but they're also working with the UN and others to bring this to the world. So we're pretty excited about that one. Another one is education credentials. So in India, there was a big scandal from 2013 to 2015 where rich students who should have worked harder weren't, and instead they were paying poorer students to write their exams for them. And then when this got discovered, the rich students' parents paid off the professors, and then that got discovered, and then the university got paid off, and then it went higher and higher and higher with payoffs, payoffs, payoffs. So it was a big scandal that lasted more than 2 years, a big problem. But this could have gone away, wouldn't have even happened if it was not possible to pay off, and instead there was transparency over the education credentials. And this is what Recruit is doing. Recruit is actually a $10 billion Japanese conglomerate, and their main claim to fame is exactly around education credentials. So they're basically putting these credentials onto BigchainDB, IPDB, in a way that it's transparent for all. So when I apply to a job and say that I have a PhD from KU Leuven, Belgium, the hiring company doesn't have to call up KU Leuven. They can just see that it's been already vetted. It's on the blockchain in a way that's vetted previously. There's more consortiums too. Innogy also working with Volkswagen Financial Services and so on. Imagine a car registry where you have the whole life cycle of the car, when it was bought, every time it was repaired, every time it had an accident, and so on. This actually really, really helps the used car market, because then you actually have a trustworthy provenance of the car, a trustworthy history of it. So we're working with Volkswagen and others on that one. Tangent 90, medical supply chain, bringing transparency there. Pretty exciting as well. Lungo Tavolo, this is a luxury brand. So a problem in the luxury world is fraud as well. If you wander around the streets of Venice, you'll see a lot of Louis Vuitton bags for sale at discount rates. But of course, you're buying them from someone on the street, so they're not real. And what if, it can be worse than that. What if you go to a pawn shop and you want to know if something is real or not? So overall, with luxury goods, you want to know, is this thing authentic? Is it real or not? And blockchain technology is a perfect way to have this record of ownership to not only help with fraud, but also as a means for the manufacturer to reconnect with the customer later in the life cycle. And there's a whole lot of other use cases too. There's more than 30 organizations building these large-scale applications on top of BigchainDB and IPDB in various places. So, for example, IP for software licensing. LicenseRocks is doing that. Financial network interoperability. Just like we have TCP/IP to connect networks of data, now there's something called Interledger, which is actually connecting networks of value. And Ripple has been rolling this out, and we're working closely with them and the IETF and others to make this happen. So connecting the various blockchain networks and so on. Loyalty and reward systems with Capgemini, think like Air Miles, right? There's a whole bunch of other supply chain engagements as well. Financial infrastructure, voting, national identity systems, social media filter bubbles, all these sorts of things. There's people building super cool applications on top of this. Basically, it's this long-standing dream that people have had with respect to blockchain, but now it's much easier to use because it actually scales, and it's just out of the box right there. So I'll wrap up there. Basically, what we've been doing has been building this software and network called BigchainDB and IPDB, overall as a means to help improve the planet using technology as a lever, right? For personal data, compensating creators, and more, right? And the essence of this is a shared database for the planet, fundamental internet infrastructure. With that, I will close and say thank you very much. Open to questions.